to hack into Bitcoin or to, yeah, basically hack Bitcoin, they would need 51% of that power to basically overpower the network and take over the network, right? So 100 might have been a bad example because that doesn't sound like a lot, but basically any government or a bad actor needs 51% of all of the computational power of the entire Bitcoin network in order to hack the network, right? So this is why Bitcoin's never been hacked, because there's so much there's so much power behind all the miners, validating all the transactions that it just makes it very, very expensive for a government or a corporation to try and hack the network, right? So they would have to put up all of this upfront cost just for the chance of hacking into the network. Does that make sense? So yeah, that's pretty much it about proof of work. Whereas we talk about proof of stake. Proof of stake is basically, instead of putting computational power towards the network and actually supporting the network in a hard way, I guess you would say, or a verifiable way, right? Proof of stake, you're just putting the currency itself, you're locking away, so let's say Ethereum, proof of stake. You're locking Ethereum away from yourself, right? You still technically own it, but you can't move it, right? And the reason why this isn't great is because it sort of replicates the model we already have with banks, right? And corporations, where I am already rich and I stake a lot of my money, that basically means I own more of the network than someone else who either can't stake as much or can't stake at all. So it's sort of a pay-to-play system where, the rich get richer. That's proof of stake in a nutshell. So yeah, is there any questions before I hand it back to Simon? Sorry, one more time. Hello? Yeah, great one. Hello? Great one. Yeah. So, yeah, he just said that basically a bad actor who's rich enough could stake enough to the point where they can then change the protocol itself. So, yeah, it's pay to play. It defeats the purpose of the decentralization, right? So it just puts the power. Hello? 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 It puts the power back into the hands of the people that we're trying to, not take it away from, but we're trying to even the playing field, right? So that these big corporations don't control everything, right? And proof of stake makes it easier for them to control everything. And proof of work makes it hard. So, yeah, that's it on proof of work. Simon, you want to take it over?
So is that clear? Yes. Basically, you have 51% overall on the system. I think you can be able to reverse transactions and put in like ultra previously done transactions. I think that's it. But that means if you were to do a 51% takeover, it means you must have that much hash power. And then you're looking at data that has been accumulated over the past decade. So even with that it's still hard to like reverse a transaction maybe that was done 10 years ago. Hypothetically, yeah, you could like break people's public keys, get their private keys. Yeah.
Yeah.
Yeah, but
Basically, just if you look into the math and the economics of it, right, to get 51% of all of the computing power, you would basically need the biggest data center in the world times 10, right? And so the cost of even attempting to do it is, it de-incentivizes you from doing it, if that makes sense. Like, if you could do it, it would cost so much to even get to have the possibility to then hack the network and gain money, right?
And then you're also devaluing the whole value of the network. So your cost just went from 50% of the cost. Now the whole network's worthless. So your cost is like double.
It's another great point. Yeah, thank you. So what he said basically is, if you were able to hack that network, right, then you're devaluing the currency that you're hacking, right? And then it makes the value of what you spent to hack even worth less. So, yeah, great point. Great point.
Awesome. Thank you, Scott. I think we'll look into hashing. So earlier on I mentioned, okay, I've seen there are few people who have mentioned. So basically what we've covered between the network, between the protocol, and then between the asset. So in the protocol level, we talked about transactions. So Bitcoin is made up of transactions, and in these transactions, they're stored in a block. So yeah, that's just a minor preview. But for now, I mentioned hashing earlier on and how blocks are formed. So I'll just demo a simple tool that does that.
so this site is just for academics. So it shows like what happens when, like how proof of work works. So if I come here and click mine, you see the computation happening. So when a new block is formed, there's something we call the nonce. A nonce is a random one-time occurring digit. So this is the nonce. So if I mine again, you see like each block usually has a different nonce from the previous one. So this is block number one. So if I go ahead and mine, the thing I was talking about, the double linked list. So you see the new block is referencing the old block. So the first block had this hash, the 008, and you see block number 2 has to refer back to the first block. So it takes the first block's hash, uses it as an input, and then gets an output, which is its new hash. So that's what I was saying, like you get two inputs and two outputs. And then if I mine again on the third block, the same thing is happening. Same thing, previous hash, and then there's the new hash. So in some cases, as I was explaining before, so this is what counts, like there's something we call a chain split. So basically what a chain split is when you have like two competing miners, right? So each of them gets a block. And then if the broadcasted
block is not mined by someone else, then you have, like, if whatever you mine is not agreed upon by other nodes, it means that you're off the chain. So, but if you broadcast your block and then it's mined by someone else, and then someone else mines on top of that block, it means your block is valid. And hereby, the 6 confirmations, like 6 blocks later, it means you get your reward, which is like 3.1. It gets credited to your wallet. So it's not only the first block that determines whether your block is the winner, like it has to be verified like 5 more times. And then after that, now you can spend your reward. I hope this is clear. Yes. The nonce is random. It's random and unique. As you can see, each block has a unique nonce. So what happens if I try and mine again? You see what happens each. And then I come back and mine here. Okay, the website is crashing, sorry. I guess the code I didn't put that into my, like, the attack you were talking about, like trying to reverse a previously mined block. I hope that's clear. Then this site whereby you can see like a basic simulation. Yeah, basically a block contains many transactions. So when you hash it, and the Bitcoin hash function is the SHA-256. So every time you hash, you get a unique representation of all these hashes, of all these transactions. Sorry, as you saw previously. So for example, this is lava. So this is the block hash. This one. So if I click on it, this now displays maybe a later block. These are the early ones. So let's say block 2. So by the hash, this block hash, you're able now to view all the transactions that happen in that specific block. So it's like a pointer to any transaction that has happened, or any transaction that is compressed into that block. And then each transaction has a unique transaction ID. So this is the Coinbase. You can see this guy, and this goes to the miner. And then we have people who transacted that time. So this address, you can see it received 102 Bitcoin. And then if you check more on the how many addresses or how many players were involved, you see 2 players were involved. So one sent 55 and the other one 46. So we want to explore more on the blocks as I have shared previously. Check on mempool.space. There you're able to like view, audit, and see each and every transaction detail. So this is a basic simulation of how mining works. But then again, I want to show you an application which you can install or to install Polar. So Polar is a tool that helps you to fire up like Bitcoin node and a Lightning node. So this gives you a basic simulation of how the Bitcoin Lightning network works. So for now, we can just do something simple. Call it a test. Or we call it NBO. So here we have, this is our Bitcoin node. So we have 3 Bitcoin nodes. So let's try and simulate mining. So for node 1, we can do a quick mine. You see, like we have some BTC, but it's still immature. So we have to mine again until we have a spendable. Let's first connection.
So let's mine on it, these other nodes. So it's a basic simulation of how mining works. And then we see what happens to our first node. So as you can see, the block height is increasing as I mine. So we are at block height 11. So if I mine on this 2, you're seeing like it's keeping track of the whole blockchain ecosystem, the whole Bitcoin network. So let's try and do the 6 confirmations. Okay, it's taking time to verify. Maybe I have to wait, but you can download this, then you can play around with it, do the mining. Then now tomorrow I'll show you how you plug in the Lightning network. So this is the Lightning network. But for now, I can show like how we send Bitcoin from node 1 to node 2. If I want to send to node 2, I'll come here and say options, then first mine. Do you get anything? Yes, it got some blocks. So I want to send some coins. So in sending, we want to send from Bitcoin 2 to 1. So I come back to 1, I get the address. I think for this, it's a bit different. Sorry. Think about live demos. Okay. So this is the terminal. So basically, in a normal Bitcoin node, you have something we call the Bitcoin CLI. It's like a command. It's an interactive way of interacting with your node. So if you want a new address, you do something like you type Bitcoin CLI. Then you say something like get new address. And here we get our address. So if you want to know about your, like how much you have in your wallet, so you say BitCLI, the same thing. You get balance. So there are two options. You can either say get balance. You're seeing we have 0. And then there's the other bit whereby you say you want to know more about your wallet. So you say get wallet info. And you can see we have an immature balance. So when you get the wallet info, it shows you like everything pertaining your balance. So the immature balance means you have Bitcoin, but it's not yet confirmed, so you can't spend it. So until it's under the balance, so once it's confirmed, it comes here to balance. So for now, we can't send until the Bitcoin is fully confirmed. I don't know if you have any questions. Any questions? So download Polar in the meanwhile. In the meantime, sorry. I think the password was, what's the password? Yeah. So it's Jenga. Sorry? So the Bitcoin, he's asking about how the balance matures. So the Bitcoin becomes spendable after 6 confirmations. And we know each confirmation takes 10 minutes. And 6 confirmation means those are 6 blocks. So it's 60 minutes. Yeah. So each confirmation means a block. So after 6 blocks, your Bitcoin now becomes spendable. Okay, nowadays it depends on if you're on the core wallet or the hardware wallet. It means, yeah, you have to wait until the 6 confirmations. But some wallets try and navigate through that. So after 3 confirmations, you're able to now like send. But the one for Bitcoin, it's 6 Bitcoin core. Any other question? So my Polar seems to be having some issues.
That's it. You and I.
Yeah, that's what exchanges do. So they trust like you're their client, so they can do 2 confirmations. It's more of trust basis, but to fully, like for Bitcoin security, yeah, 6 is the least. Yeah, I guess that's it. Any questions on the general? Has anyone run up? Yeah. Block heights. So basically, let me go back to my simulator. So the basic definition of a block height is how many, it's like how many blocks have passed. So in our scenario here, we could see, okay, actually let me go back to Polar. You see, the more you mine, each new block, it means that's a new height. And the height is the maximum level of blocks that have been mined at that current time. So in this moment, we are at height 34. So that means our simulated direct test has 34 blocks. So if I mine again, I'm adding a new height. So each time you mine a new block, you're getting a new height. So it's the maximum height of a blockchain. Yeah, Polar is basically, it helps developers like, what do you call it, bootstrap or test their solutions. So it helps you to fire up a Bitcoin node, connect it to a Lightning node, and then if you're checking here, it also allows you to connect to your node. So you can do like a basic API whereby you connect to your node, query it, and you can be able to do simple transactions, verifications. You can do a basic explorer on it. So Polar allows you to like do quick testing and developments. Also, it's good for simulating your network. So if you have a solution or a feature you want to test or a product, you can use Polar for that. And then, but then again, we have for Bitcoin itself, we have something called the RegTest, which is a testing network. And then you have the testnet and Signet. But now, RegTest is a local network whereby you can have simple nodes. Like you can have, let's say, like 3 nodes, like your own local network. But when you're developing on Signet, it's a public network. So when you mine, your node, whatever you mine there is being broadcasted to other Signet nodes. So basically, for those who are curious, if you want to run a Bitcoin node, or that's after class maybe. So you can come to bitcoin.org. And here you can have this. These are the Bitcoin Core wallets. So you can download this and you can test it at your own free time. It covers both Windows, Apple, and Linux. So those are the binaries. So that's it. Yeah.
For points,
Basically, reg test. It's your own local network.
any other questions?
General Bitcoin question. You wanna do that? You wanna do that? Okay, you can create a new network and start from scratch.
If someone asks a link of this to load it.
Okay.
Have you managed to download Colab?
Hey guys, can you hear me through this mic? I'll just speak loud. Oh, you okay. Gotcha. Okay. All right, so I'm just going to take you through Polar a little bit. We're jumping ahead, right? Because today we really just talked about Bitcoin's base layer, right, on chain, whereas Polar has on chain, but it's really meant to develop the Lightning side of things, right? Because without something like Polar, there's really no visual way to, click around and build nodes and open channels, which will make more sense when choosing to do it. But yeah, without this, you're basically just writing commands. It's kind of hard to conceptualize things. So Polar helps you, basically helps developers test, build new things, etc. And it'll make more sense once I show you. So here we go. So every time you create a new network, it's basically just a simulation of a self-contained Bitcoin network, basically. So here we go. And again, we're jumping ahead because this is more Lightning. Tomorrow will be more about, what Lightning is, why it was created, why it makes Bitcoin better. And but yeah, this is just fun to be able to see a bit about what you'll be learning tomorrow and the upcoming days. Okay. Alrighty, so every time you're in Polar and you create a network, you basically have to start it, and this simulates the actual, blockchain, mining, etc. You have to wait a bit for all of the software to start up. So just give it a second here. Are there any questions while we're waiting for this to start up? Oh,
If there's any special information on the emergency setting up for
any special what?
consideration when you're setting up the
Great question. So there's not too much to know. There's a couple things. So if you look at the board or the screen, right, you can see there's these different symbols, right? Here's the lightning, and this is a different one, right? And then this is different. So in that screen before, I basically told it how many of each of these nodes I wanted, right? And the difference in these, they all run on Lightning. They all run on Lightning, right? They're just different implementations that offer you different benefits. Some are easier to build on, some they save you money when you're using them, etc. So there's kind of trade-offs depending on what type of node you want to use. I would say this one, LND, is the most popular, probably the easiest to use. And it's just taking a while. But yeah, besides that, there's not too many special considerations. Ah, all right. Simon brought up a good point here. Let's try, oh yeah, so there's 5. That's way too many. So I'm just gonna do LND. So I should have talked about this earlier. These are the different types of Lightning nodes. They all do the same thing at the end of the day, but they just do it a little different. They're just different implementations of the Lightning protocol. So for this demo, we're going to take away core, take away eclair, and we'll just do 3 LND. And hopefully this one starts up a bit faster here. Way faster. There you go. All right, so now you can see the nodes are online, right? But they're disconnected. There's no connections between them. So they're basically useless. You can't send money between them. So the way that Lightning works is it's all based around the transactions that you learned about today, right? But what's cool is instead of thinking of the transaction as a one-time thing where you send the transaction, let's say it's 1 Bitcoin, and it's sent, and then it's done, what makes Lightning special is you use that transaction as a channel that then basically serves as a street to send Bitcoin back and forth much faster, much cheaper, and more private. So it might make more sense when I show you. So as you can see, I'm opening a new channel amount from Alice to Bob. And the capacity, so this is, again, you'll learn, this will make a lot more sense tomorrow, but this capacity is based on that the transaction you learned about today. So right there it says 250,000 sats. So that means that in that channel between Alice and Bob, they can send any amount from 1 to 250,000 sats between each other. So it's the capacity of the channel. Okay. Alrighty. So now Alice and Bob are connected and they can send money back and forth. So I'll show you that really quick. So in Lightning, instead of transactions, things are called invoices. It's just a layer on top. Again, we'll learn more about it tomorrow. But let's do that. So Bob is going to create an invoice of 50,000 sats. And then Alice will pay that invoice. All right. So Alice just paid Bob 50,000 sats, right? It was immediate. It didn't have to wait for confirmations on the blockchain or any of that. It's essentially instantaneous, which is why the network is called Lightning. So another thing that's interesting, what if Alice wants to send Carol money, but she doesn't have a connection, but Bob does? Let's open a connection. Carol and Bob. Sweet. So now Bob and Carol are connected, but Alice and Carol, as you can see, are not. So the beauty of the Lightning Network is Alice is able to pay Carol, even though they're not directly connected, through Bob. And every time that happens, Bob makes a small fee. Yeah, so let's.
Not working for it. Can you pay for it?
All right, let's try it out. So Carol is going to generate an invoice. Alice is going to pay that invoice. Cool, so it worked. So as you can see, it's pretty cool because in Lightning, you don't have to be directly connected to someone to be able to pay them. And this makes it just much easier to use and cheaper. So this, in Lightning, this is called a hop, right? Because the money hopped from Bob to Carol. And in Lightning, I think what is it, 10 hops, you know? A transaction can take 10 hops. So this basically just enables you to be able to send Lightning to anyone in the network, even if you're not connected to them. Yeah. So anything else you can go to show? So that's pretty much it. That's pretty much it for the Polar demo. As you can see, it just enables you to test the Lightning, sending sats between different nodes. And yes, this is just giving you a little taste for what you'll learn about tomorrow. And then Wednesday and Thursday will be much more hands-on. You'll actually be able to use our company's API and another company link to create these invoices, send money back and forth, and really get a feel for why Lightning is so cool. So yeah, thanks for coming. Yeah, excited to see you these other days. Simon, yeah. Yeah, what's up?
Regarding the hot, I think I heard you mention that for Alex to send funds to Carol, Bob is the one who's gonna pay the transaction fee.
No, he makes the fee.
Oh, he makes the fee.
He gets paid.
Maybe you could just mention.
Yeah. Sure. Great question. So he asked oh, he was on the mic, sorry. Anyway, yes. Awesome. So, right. So the way that Lightning works, the way that Bob is incentivized to send along the money is that he gets to take a very small percentage of the transaction. So basically, Bob is incentivized to send along the money from Alice to Carol because he's going to take a small fee. Does that make sense? Cool. Yeah. Any other questions?
So when Alice is saying the money has to go, right? I don't know if you mentioned it, but why do we really need Bob to be an intermediary between the two? And who pays for the transaction?
Great question. Great question. So the reason why, well, you wouldn't need Bob. You would just open a channel between all of them, and you'd be fine. But when you open a channel in Lightning, that's real money, right? That you're putting on the line, that you can't necessarily, you can touch it, but it's sort of locked in that channel between those two people. So every time Alice would open a channel to Bob, if there was no way to hop from Bob to Carol, then Alice can only send money between her and Bob. So the hop enables you to send to, basically, without having to commit funds to Carol between them, you can still send money to Carol. Does that make sense? Another great question. So no, it's not expensive. It's very cheap. It's usually another interesting thing about Lightning actually is, so earlier you learned that there's 100 million sats in one Bitcoin, right? Lightning breaks it down so that one sat can be broken into 1,000 millisats, okay? So why they did that is because not only does Lightning, make transacting cheaper and faster, but you also want to be cool. So not only does it make it cheaper to send Bitcoin, it makes it faster and more private to send Bitcoin, but the other beautiful thing about Lightning is you can send tiny amounts. So on Bitcoin's base layer, it doesn't really make sense to send one Satoshi. because the fee might be 1 Satoshi, 2 Satoshi. So you might be paying more in fees on chain than that small amount. Whereas Lightning, since the fee can be in milli-Satoshis, you could essentially send 1 Satoshi for 1,000th of the Satoshi. Does that make sense? So yeah, if let's say Alice is sending Carol 1 sat, Bob might make, you know, 100th or 1,000th of that sat. Right? So it's very cheap, but the idea is, in this scenario, Bob would be called a routing node because he's routing the money from Alice to Carol. These routing nodes are expecting high volumes, right? So let's say that he routes, 1,000 payments. So even though it's cheap to route that, he's making a small percentage every time he routes the money through. Yeah, does that make sense?
So every node operator gets to set their own fee, right? So the dynamics of the economy is down to like,
Exactly. Yeah, great point. So it's a very competitive environment to be a routing node because, like you said, Bob chooses. This is a great point. Thank you for mentioning it. Bob sets the fee. So each person gets to set the fee that they make on the route. So it makes the environment much more competitive because let's say there's another person here who is, Alice will be able to send cheaper through this person up here, Bob, she's going to send it through that cheaper person. So yeah, it makes the environment very competitive. It keeps the fees cheap because everyone wants to be making this, constant transaction fees, basically.
So, in the process where we want to add a new player, I'm trying to understand how that new player probably add it to the channel.
Awesome. Yeah, great question. So you're basically asking how Carol receives the money from Alice in this scenario? Yeah, let's do it. Um, um, okay, so we have Dave. So yeah, right now Dave is totally unconnected, right? He's not connected to anyone. So let's connect him to Carol. So that's sorry, Mom. So yeah, it's a great question. So to be on the Lightning Network, you have to have at least one channel open, right? You can have hundreds, you can have 10, it doesn't matter. It matters because it costs money every time you open a channel, but you would need at least one channel to be connected to the network. That's, Oh, I'm not sure. Sure. You brought up a good point here, is that, so all of these little transactions are on the Lightning Network, right? But opening channels is on the actual core Bitcoin network that you guys learned about today. So all of these transactions are instant, but opening a channel in real life can take, a day or however long that on-chain Bitcoin transaction takes. But once it's open, it's open. You can transact however much for however long you want. I don't know why that didn't start, but I think I answered your question, right? You need one channel. It doesn't matter to who, but hypothetically, you want a channel to be someone. So in this scenario, Dave would most likely want to be connected to Bob, because that way Dave is connected through Bob, both Carol and Alice, right? So if you have a node, you can get away with having one channel, as long as that channel is connected to what we call a well-connected node. These tend to be Lightning companies, people really transacting on it. Anyone else have a question? I'll come back to you.
So is it possible to have a multi-channel? Say like these so you say like people stream and then you answer issues. Is that how it works or how does it work?
You said monitoring?
No, multi-channels, like one person connects to
Good question, yeah. So channels are always just between two nodes, right? Yeah, so, but a well-connected node would be someone like Bob who's connected to multiple people. Great question. So now we're talking about the actual, how this, network works, right? So let's say, so when you open a channel, normally one person opens the channel to another. Now there's newer technology where you can split the opening and sort of both parties put up half of the cost of the channel. And then that way the balance is equal. But in the typical scenario, Alice opens a channel to Bob, let's say just for 100 sats. That means that the direction is from Alice to Bob. So in the beginning, in this scenario, only Alice can send and only Bob can receive. But once Alice sends, let's say 50 to Bob, now the balance in this channel is 50 Alice and 50 Bob. So now they can both send between each other freely, right? But then let's say Alice sends all of hers to Bob. Now only Bob can send and only Alice can receive. So visually, you can kind of think of it like waves or like waves of water where, as the Bitcoin piles up into Bob, he can, since he already has all the Bitcoin in the channel, he can't receive more. He has to send more out to be able to then receive it back. Now, this might seem weird, and this is where having multiple channels makes sense, because you want to be able to send and receive kind of all the time, right? You don't want to be limited to only sending or only receiving. There are certain scenarios where, let's say you have a company that just accepts Bitcoin payments, okay? That would mean that you only want what's called incoming liquidity or inbound liquidity. So that would mean that you have Alice pointing to you, you have Carol fund pointing to you, you have Dave's fund pointing to you, and this enables you to constantly receive without having to worry about rebalancing this channel, right? Yeah, does that make sense? Yeah, great question. Yeah, so let's say Alice wants to send Carol 100 cents. That would mean that on this side, Bob would have to have outgoing liquidity to Carol of at least 100 cents. And he would need to have 100 cents of inbound from Alice, right? So this is getting really into like the deep technicalities of how Lightning works. And once you learn more about it, you'll kind of see why not everyone most likely will run a Lightning node, because it takes a lot of work, honestly, to keep these channels balanced between, everyone, like let's say you're Bob, and you want to be able to send and receive constantly. You are in charge of keeping these channels balanced. Again, this is, we're getting pretty deep. We'll learn more all this tomorrow, but yeah.
When I have actually wallet, you have a node. So that the wallet automatically detects any node or is for a particular node.
Good question. So if you have a Lightning wallet, is it detecting certain nodes? Basically, when you have a Lightning wallet, depending on how the wallet's built, you're either using their node, right, the wallet's node, and so you're depending on your wallet's node to be well connected. Now, there are other wallets where the wallet itself is a Lightning node, right? And depending on how it's built, you either have to manage the channels, like I said earlier, yourself, or a good example is Phoenix Wallet to check out, where you own your keys, you own the node. It's a sort of a lightweight node on your phone, and it manages all of the channel rebalancing for you. Now, I'm sure they're taking a fee for this, a very small fee, but it makes it worth it because I'm telling you from experience, managing one of these nodes is, like I said, a decent amount of work, but there's money in it. It's hard to be profitable, but it's very doable, but you just have to be good. Like I said, it's a very competitive environment, like you brought up earlier, so yeah.
It's also important to note that if you're building a platform outside of just the walls, different tools, so that you're going to go through Link and IDEX. Link, you find your own channels. Business options will developers options.
Yeah, Rise would bring up part of our value proposition, which is, let's say you want to build on Lightning, and let's say that you don't want to have to necessarily commit all of your funds to channels. So certain APIs require you to put up your funds to then, use the API, right? Whereas IBEX, we provide the liquidity, right? So you still have to send in the money, but let's say IBEX gets hacked. It's IBEX that's losing the money, not you, because you have your balance, if that makes sense. So, yeah, again, this is getting pretty deep into the Lightning, but yeah, great question.
Let's say Dave wants to Carol and wants to send sats to Alice. Since Bob and Carol have set a fee to manage the transaction, how does Dave accumulate the cost and put it in the transaction amount sent?
I see. So you're sort of asking like how Dave predicts how much to send because he has to account for the fee being taken. Deep question. Basically, it depends on the type of node you're using. Some of them manage it for you. Some of them, it really is, the way that Lightning works is it's sort of opt-in where the more work you put in, the more, it depends on what you want to do. Some people want, like let's say Bob is a hardcore routing node. He's really trying to make money. So he would be someone who is very deep into setting all of the parameters for the minimum fee that will take to route a node, etc. Right? Whereas let's say someone else is more casual, they won't get into all of these details as much to, you know, optimize their node and optimize. Does that answer your question? Yeah.
I guess from what I understand, in this case of a new player coming to the network, in this case, Dev wants to, I guess it will be cheaper for Dev to make a transaction to make a connection to Bob directly than to pass through Carol to be cheaper. And is there a way to make that increase?
Yeah, good question. So again, that depends on the Lightning implementation you're using. So that goes to what pathfinding algorithm the implementation uses. So for example, this is LND. They have a specific pathfinding algorithm, whereas the other types of nodes like C Lightning or Eclair have their own way of doing it. So again, yes, we're getting like super deep, super into the weeds here about how Lightning works, but I'm glad to do it. But yeah, again, it's sort of just how much effort are you willing to put in to do it, right? Because the casual user just wants to be able to send and receive money. They don't necessarily care about optimizing to the, you know, nth percentile. But, and that's just a casual user. But if you're Bob, who is trying to make money on the Lightning Network by routing its payments, you're going to put much more time into, you know, fee management, keeping the channels balanced, etc. That makes sense. Cool. Any other questions?
So when Carol prints an invoice, he says, I want 100 sats. The wallet of the sender is going to calculate the route and say, okay, you need to pay 105 sats to send this through. Is that correct?
Exactly. Yeah.
So the invoice doesn't have the fees in it yet.
No, the invoice doesn't have the fees, but the wallet will predict the fees, basically, depending again on the algorithm, the path, finding the shortest path, basically. So is a good point. Let's say this network was much bigger, right, where there's hundreds of people, and Alice wants to send to Carol for the cheapest. These implementations, right, LND, Sea Lightning, Eclair, are always going to try to find, not always, but most of the time, are going to try to find the shortest path between these people, right? Because the more hops, the more you're paying in fees. And the wallets, you know, take that into account. They do it for you, basically. Cool. Any other questions? And, you know, over the next couple of days, just write down any questions you think about, because we're going to go much deeper into Lightning, especially tomorrow with the theory, or, you know, why it was created, and how it really works. And then Wednesday and Thursday, again, we'll get our hands dirty, and you'll be able to use APIs to actually see how it works. And one of the nice things about most APIs is all of these technical details are taken care of for you. So for a lot of people, like businesses, they don't want to have to manage their Lightning node, right? Because that means they need someone that knows how to do that. So they're paying that person to manage the Lightning node, right? So yeah. Cool. Well, thanks everyone for your great questions. Really appreciate you being here. Simon, do you want to say anything else?
So basically, we pause it for there right now. We'll have our lunch break. And then afterwards, we can learn more on tools. And then after that, we do Q&As and a takeaway assignment for tomorrow. Yeah, so stick around, don't go away. Also, if you interact or
Thanks, man.